simplify radicals with binomials. We can only pull factors which are separated by multiplication out of a radical. If we have terms, which are things separated by adding or subtracting, we must factor first. Remember, a binomial is something with two terms, such as x plus y. Let's look at example 1. Here's example 1. As you can see, this is a binomial with two terms because there's a subtraction sign in the middle. We can only take out factors or things that are being multiplied together. This means we must factor this. Let's start by taking out whatever they both have in common. I know I can divide both of these numbers by 4. I also know that both of them have at least an x squared in common. This leaves 25 minus 4x squared. Remember, this is still in the square root. Next, I could continue to factor what's inside the parentheses. This would give me 4x squared, parentheses, 5 minus 2x, and 5 plus 2x, because this is the difference of squares. Once again, it is still inside the radical. Now we can factor out anything that is being multiplied by something else. As you can see, the 4 is being multiplied by the x squared, which is multiplied by the quantity 5 minus 2x, which is then multiplied by the quantity 5 plus 2x. Let's start with the 4. The square root of 4 is 2, so a 2 can come out. Next, the square root of x squared is x. Remember, you take the exponent and divide it by the index. This leaves us with 5 minus 2x and 5 plus 2x on the inside. As you can see, these two do not match, and therefore we only have one of each of them. Since the index is 2 and we have to have at least 2 of something to pull it out, these need to be multiplied back together. This gives us 25 minus 4x squared. This stays on the inside, and 2x, which stays on the outside. We have now completely factored this, and this is our answer. Let's look at example 2. Here's example 2. Once again, we have a binomial with two terms. So we need to begin by taking out whatever they both have in common. They both have 27 in common, along with x to the 6th. This leaves 8 minus x to the 3rd on the inside. Remember, we still have a cubed root. 8 minus x to the 3rd is the difference of cubes which can be factored, but since none of those factors match, and none of them will therefore have an exponent higher than 1, we will just leave them as it is. Let's find the prime factorization of 27. Remember, the prime factorization of 27 is 3 to the 3rd. Now we can take each of the exponents and divide them by the index to see how many come out and how many stay in. For 3 to the 3rd, 1 3 comes out and there are none left inside. For x to the 6th, Two x's come out and none stay inside. This leaves us with the cubed root of 8 minus x cubed on the inside. Remember, you cannot take anything else out, even though it seems as if this x to the cube could come out as an x, but remember, it is connected by addition or subtraction, and we can only take out factors that are connected with multiplication. So this is our final answer. Remember, when you're simplifying radicals, if they are binomials or anything with an add or subtract symbol, this means we must first factor out anything they have in common and then determine what comes out of the radical.